Alright, I'm not sure where the video cut out, but we're going to just start in and say, alright, so u is x, du is e to the x dx. The derivative of x is dx, and the antiderivative of the x is e to the x.
What color is Juanita's hair?
So now, here's where we use the formula. The integral of u dv equals uv. So x e to the x minus the integral of v du. So e to the x dx. Hopefully the integral of v du is something you can do. So what we end up with is x e to the x minus, what's the antiderivative of e to the x dx? E to the x plus c. So the integral of x e to the x is x e to the x minus e to the x plus c. All right, good. All right, let's do next example. How about the integral of x secant x tangent x dx? U, v, du, dv. I want everyone to take a minute in your group, see if you can find u and dv, see if you can split it up properly, and then find du and v.
Good thing we have the power couple right here. JP and Nelson.
Okay.
Not Jacob. That's hard.
There we go.
They didn't even finish their quiz. It's quality, not quantity. I don't know if that applies for quizzes. Yeah, I don't know if that applies if you want to do a third of the quiz. I bet you differentiated to the wrong variable every single time.
Would you consider the...
That's it, just Andrew, right? That's all I see.
If you guys get below 5, I'm going to laugh so hard. You get the kicked out of this class. One time Chandler got like below a 5 or he got below a 60 in a physics test, and I was laughing so hard I had to be asked to leave the room.
So let's start with dv. I usually find dv first. What's dv?
Secant x tangent.
Secant tangent. Very good.
Secant tangent. How do you, like...
Well, I think there's some x's in there.
Yes. And then u is x. Yes,
So
but
we said to treat the more complex function as dv, so we can treat, like, multiple trigonometric functions. Like if that
it's
was...
the biggest part where you can find the antiderivative.
Okay.
Right? You could do just the secant and you could do the antiderivative, but if you can do the antiderivative secant tangent, take as much as you can and put it here.
Okay.
You want this to be the bulk, if you can. So what's if u is x, what's du?
Yeah.
Dx. If dv is secant tangent, what's v? Secant, because the antiderivative of secant tangent is secant. All right, everyone take a minute and write what this is equivalent to and see if you can find your final answer. Might have a little tiny blast from the past in this one. Okay, so the integral of u dv equals uv, so x secant x minus the integral of v du, which is secant x dx. So we get x secant x minus, what's the integral of secant? ln
Absolute value.
absolute value
Secant plus.
secant plus tangent. So you get ln absolute value secant x plus tangent x plus c.
That's joyous.
Yes. All right.
So you're basically when you're writing the answer to that, you're pulling from the u e minus the integral of v du.
Of VD.
So then
And then you have to process this integral.
that function though, it would say that it's. Wait, hold on. Wait, okay, I got it.
You got it?
I got it.
Okay.
I think you got it.
All right. Hey, it's time to learn the antiderivative of a function I'm sure you've always wondered about. And the antiderivative can only be found using integration by parts.
Is it 1 over x?
Ooh,
1 over x.
Rayon just called it.
Oh,
Let's find the integral of ln x.
That's joyous.
All right? So we have a u, a v, a du, and a dv. There's a trick.
There always is.
dv is the largest part of this function where you can anti-differentiate it. What would dv be? Just dx.
Yeah.
Because if it was ln x, then you would just write the answer, right? Right, okay. So dv is actually going to equal dx. So what's u?
ln x.
ln x. All right, so if u is ln x, what's du?
1 over.
Yeah, you got it. Yeah, no, 1 over x dx, right?
Measured.
If dv equals dx, what does v equal? X. Take a second, find the answer.
Oh snap. Oh slow. Oh snap. What's the next one? Juanita is 4'9", 5'3", 5'6", or 5'2".
4, 9.
5'2".
5'2", is that
That's
your
my
five?
guess.
Ooh, it was 5'3".
Ah,
So far you only got one question right.
I didn't even
Juanita's-
answer enough.
Well, the first one was what color is her hair?
Brown.
Yeah.
Christ, my roommate's in this class. Can you guess who it is?
Your roommate is in this class? Oh, your future roommate.
No, Who is
It's
it?
not Noah?
It is Noah. Like, I don't know why.
All right, here we go. So uv x ln x minus the integral, hey, what does x times 1 over x equal? 1. So it's just the integral of dx, right? So we end up with x ln x minus, ooh, what's the antiderivative of dx? X plus c.
So can you always like factor out a like
X times the quantity ln x minus 1?
yeah?
Yeah, you could.
But like with the, just all of these, could you like factor out?
Not necessarily.
Oh, because you couldn't factor.
Like, you can't do anything there.
Okay.
Yeah. Okay, any questions? Let's do tab method. So that was the long way, right? Which isn't that bad, right? It's not bad.
So easy.
Okay.
That's what I'm gonna do every time.
Oh, just wait till you see tab. I think you're gonna change your mind.
This
Alright,
is
you
like
need the first 3 girls in the
It's
front.
like a refreshing.
when we learned that one
Okay.
thing. We said
So-
two limits by hand. If you know, like that long limit way, then we go the shortcut.
Kind of,
Okay, done.
kind of. Okay, here's tab method. Now here's the thing. The only time you can use tab method use
They're all disruptive.
when you have a polynomial
Hey, mine are all very easy.
times a function that you can integrate. I can't write. Repeatedly.
What does integrate even mean?
Anti-differentiate. So, for example, e to the x, right? E to the x, I can integrate forever. Hey, what's the integral of e to the x? E to the x. What's the integral of that? E to the x. What's the integral of that? E to the x, right? But there are other functions that you can integrate forever, like sine. What's the integral of sine? Negative cosine. What's the integral of negative cosine? Negative sine. What's the integral of negative sine? Cosine. What's the integral of cosine? Negative sine, or sine, right? You just, whatever, you just keep going. You can keep going forever, right? So this works when you have a polynomial. You have to have a function that can differentiate down to 0. It's got to be a polynomial times a function where you can repeatedly integrate it. Do multiple iterations of integration. All right? So here's how it works. I'm going to give you an example, and I'm going to show you what would happen if we were to do this the long way. So we're going to find the integral of x to the 4th times sine x. You can write this. Don't write what I'm about to do. If we do it using the traditional integration by parts, here's what happens. What would go in dv? Sine x. So u would be x to the 4th. So du would be 4x cubed dx, and v would be negative cosine x, right? So here's what you'd end up with. You'd end up with uv, so negative x to the 4th cosine x, oh, whoops, minus the integral of v du, so negative 4x cubed cosine x dx. This is all well and good, but this integral requires what? Integration by parts, again. And what we'd end up with when we did that would be an x squared times a sine function, and we'd have to do another integration by parts. And you would have to do integration by parts 4 times to get through the whole thing, right? So, and it's very convoluted, right? It takes a long time. So rather than doing all of that work, that's why we have this wonderful thing called tab method. Alright, so here's tab method. When you use tab method, you have a u and you have a dv. U is the polynomial, and dv is the other function. Don't put any dx's or plus c's or anything, just the two functions. So for this problem, u is going to be x to the 4th, and dv is going to be sine x. Alright, y'all with me? Okay. Here's what you do. You start with your polynomial and you differentiate until you get to 0. So, what's the derivative of x to the 4th? 4x cubed. What's the derivative of 4x cubed? 12x squared. What's the derivative of 12x squared? 24x. What's the derivative of 24x? What's the derivative of 24?
Christmas tree.
Okay? So you start with a polynomial, you differentiate all the way down to 0. Then you start with your other function and you anti-differentiate for every single row that you've got for your polynomial. So, what's the antiderivative of sine? Negative cosine.
Negative cosine.
What's the antiderivative of negative cosine?
Negative sine.
Negative sine. What's the antiderivative of negative sine?
Cosine.
Cosine. What's the antiderivative of cosine?
Sine.
Sine.
And then we'll be
What's the antiderivative of sine?
negative cosine.
Negative cosine. One more step. Over here, next to your u column, you want to make kind of a third column. You always start with plus, and then you alternate with signs. So we go plus, minus, plus, minus, plus, minus.
Here we have a negative 0.
Now you really can. Yeah, the last row you really don't have to write. That's okay. All right. Now we're going to do what Mr. Escalante in Stand and Deliver calls tic-tac-toe. All right? So you go across and diagonally down.
This isn't
Okay.
math anymore.
So you take the sign times this times one row below. And you just go diagonally down, diagonally down, diagonally down.
Did you ever play MASH when you were a kid? To find out like where you were gonna like live and who you were gonna marry and stuff like that? This reminds me of that.
Oh.
It's just very tedious.
Okay. And here's our final answer. Positive x to the fourth times negative cosine x gives us negative x to the fourth cosine x. Plus negative 4x cubed times negative sine x is positive 4x cubed sine x. Plus
So you're multiplying.
positive,
these
you're
together?
multiplying. Positive 12x squared times cosine x is plus 12x squared cosine x.
Oh, God, you have to write all this down.
Plus negative 24x times sine x is minus 24 sine x.
And then it's just
Plus 24
Oh.
times negative cosine x is minus 24 cosine x.
Wait,
And then
what is it?
finally, plus c.
Wait, why is it just 24 times sine x? Why isn't that 24x times sine x?
Oh, did I drop an x? Oh, I'm sorry, I dropped an x.
Oh, you're confusing me. It's
I'm
like
so
that
sorry.
time that you lied and you said we could divide out the d's.
All right,
Ruined-
okay, so there you go.
ruined my math.
This is the equivalent of having to do integration by parts, right, 4 times. So it's kind of nice.
It's actually an equal one.
I watched.
All right, you can use tab method even for the simple problems as long as it's a polynomial times another function. We're going to do one more quick example. Suppose we do,
You're supposed
go
to
back
end.
and do the example of
At
x e to the
11.
x.
It's 11. Oh, 11. Make a wish. I wish that JP would remain my partner forever. JP. We're never gonna. No.
All right.
I'm not gonna verify it.
So we're going to do this using tab method.
I'm just kidding. Of course, math partner.
What is your u? What's the polynomial part?
X,
What's your dv?
dx.
E to the x.
0.
Okay, so you differentiate down. What's the derivative of x? 1. What's the derivative of 1?
0.
What's the antiderivative of e to the x?
E to the
x.
What's the antiderivative of e to the x?
E to the x.
Then don't forget your signs. Plus, minus, plus. Those signs will get you if this is a multiple choice, right? Okay, diagonally down, diagonally down. So you end up with x e to the x minus e to the x
Plus c.
plus c.
So instead of using substitution, could you just do this?
Well, we haven't, don't confuse use substitution with integration by parts. Instead of the other method for integration by parts, you could do this. However, there might be functions that we would give you, like for example ln x, where it's not a polynomial times a function you can repeatedly integrate, and therefore you can't use tab method, you gotta do the old way.
But like normally, like if we weren't using integration by parts, we would say that x is equal to u, and then we would just like cancel out the stuff and we use substitution to get the integral. So.
Wait, you're asking me like if I could do the old-fashioned use substitution on this?
Yeah, would it give you the same answer?
You can't do this with use substitution.
Oh.
Here, let's try it. Let's try it. Okay, so Rayan, if you did this using u substitution, what would u be?
X,
So du would be
dx.
dx, right? So this would give you then u e to the u du.
Oh, I'm gonna do it.
It doesn't do anything at all. Which is why I keep telling you guys, when you do u substitution, u is never, ever, 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 ever x, because all you're doing is just rewriting the problem with new letters, right? Okay. However, that being said, and I'm going to leave this on camera just for the world to know, your homework tonight in section 8.2, there are several, not just one, several problems that don't require integration by parts, that do require the old-fashioned u substitution in order to find them. So be warned, like for example, we did, in first period, we did number 19. If I remember right, 19 was this, ln x quantity squared over x dx, right? If you have an integral like that, this is not integration by parts. This is old-fashioned u substitution. What would u be for this? ln x, because then your du is 1 over x dx, and you end up with just the integral of u squared du, right? So there's a mix, just be warned in your homework. Some are old and some are new, okay? And here ended the lesson, right? We're done. We're done.